Hey guys, welcome back to another video. So I have quite a few things to show you guys today. Let's just jump into it. The first thing, the most important thing, I fixed the memory leak. I'll get the task manager. So as the game runs after a minute, the garbage collector collects all of the objects I had to use to create the world meshes and whatnot. So it likes to sit around 207 megabytes, somewhere around there. I had to make a custom build of the game where the only thing that was rendering was the X, Y, and Z up there. But I set him to render that like 1,000 times every frame, and I was able to add 100 megabytes every time Task Manager updated. So I was like, I'm not going to move forward until that's fixed, and it's fixed. Even with this menu open, it only jumps up to 216 because these are more objects that it has to pull into memory, but it will go down anyways. It actually went a little bit lower, so that's cool. Let's see, there's a new world selection mesh. You can customize this. That's pretty cool. And then there is now this. The prototype for the digging. I think it's pretty cool. And you're gonna have to excuse my yawn. I think my brain went flat from how many calculations I was doing earlier. The reason why you can customize the mesh on the actual selection is because it's technically a mesh that I've constructed together. So I think that's pretty cool. Let's see. I'm gonna set this to render last so that it doesn't get overwritten by the water. You can see that happening right now. What else do we got here? So now there's sand, and I apologize if I'm repeating myself. This is like take 5 of this video, but there's nice coastlines, there's rivers. It's pretty cool actually. So the memory leak, we're actually sitting at 230 megabytes because as you walk, the chunk objects get created and then they get swept out of memory by the GC. But it shouldn't leak anymore because I spent a lot of time fixing that. But it will go up a bit as you start generating new chunks and whatnot, because you have to create data in memory. So we'll just keep walking here. So one of the things I didn't explain in my other video was the fact that this is now object oriented basically means I can put in dynamic view distance so you can toggle it, and then I can do a collection or a regeneration based on the toggling of your render distance. So that's pretty cool. Let's see what else is there. Mainly it was just optimizations I added in. I want to make it so you can throw a full stack off the side, and so you can sneak and then throw a full stack. Nice. So here's the part of the video where everybody leaves, because it's going to get loud. I need to make it so you can just punch stuff. I like how that didn't hit any of the other TNT. Literally the same thing happened. Alright, let's do this. There we go. Better noise. Alright, so the next focus that I'm going to do, because the oh yeah, I don't think I ever mentioned that the crosshair is inverted. I'm not sure, so I'm gonna just tell you guys in this video the crosshair is inverted. So here we go. The crosshair will actually take any shape you put into it, any texture. Just make sure it's like a white color or it's solid white, and you can make it a heart if you want. Do whatever you want with it. So I think that's pretty cool. So what was I saying? The focus the thing I want to focus on is lighting. Lighting is extremely important, and the way I re-implemented the object orientation of how the world dynamically loads allows me to actually basically make it so you can dynamically load light. I don't even know how else to explain this. Yeah, my brain went flat when I was implementing the coastlines and whatnot, so I can't even speak anymore. There's no more thoughts happening in my head. But what I'm trying to say is I want to implement things like torches and like day and night cycle, stuff like that. It shouldn't be too difficult, but those are the famous last words. Honestly, it's either going to be like, oh, this makes so much sense, or it's going to be, yeah, this is not possible. But, you don't know until you try, and if I was able to do basic lighting beforehand, with the truly horrific system that I was utilizing, I'm pretty sure I'm able to re-implement it. In fact, after I'm done with this video, I think I'll try like a basic implementation, and we'll see what happens. But no promises, guys. It might take a week. It might take a couple of decades. I don't know. But in all seriousness, it might take like a week, because lighting is very difficult. Because you have to do a flood fill algorithm, and there's ways to do it faster, but I'm not that smart. I've created a whole game engine, yes, but the algorithm to do it really, really, really fast in a voxel sandbox basically is extremely complex. So we will see. We will see. Let's see, what else do we got? Ideas. I'm trying to think of the ideas that I had earlier that I haven't already explained in videos. Also another update, we're only using 250, which is cool. I actually saw it jump up to 300 while we were walking, because the what's happening is you gotta think that, see how that chunk disappeared? Technically it is still there in your memory, but the garbage collector cleans it up, and if you program it right, then the garbage collector handles it. It'll just go up. You can actually limit the VM if you really want to be crazy. Limit it to 200 megabytes with XMX dash no, it's dash XMX colon 200 capital M, and the garbage collector will run whenever it gets close to that, which is really cool actually. So you can see how there's like rivers and stuff, all that good stuff. And you can probably tell I like literally spent countless hours trying to optimize everything to like the extreme, and I think it actually worked. So I'll keep walking on the negative z-axis. So another thing I want to try, well, not that I'm going to try it, that I'm going to do, is implement basic world saving. I don't know how to do that yet, just being honest here. I have no idea. I was researching a bit into JSON and then database technology. The JSON seems easier, and you can actually modify your chunk data without a external saving program, or sorry, external database program. But it's going to be a little complex, and we're gonna have to see how everything pans out. and you can see the garbage collector just swept. And by the way, this is actually, I know that Minetest uses like a little trick to reposition your actual client so that you don't have float imprecision, but what's happening here is you're actually where you are is actually where you are in memory, like in a literal sense. In your GPU, you are this far away. It's crazy to think about, actually. Not sure how the OpenGL is going to like people walking really far, though. We'll definitely have to see. I can't wait until somebody just loads up this game up and it's like, yeah, we're gonna walk all the way to the edge of the map and see what happens. Be like, no, don't do that. You're gonna crash the game. And somebody probably will crash the game, but that's okay. Another thing I want to try to implement is trees. I thought about this today, and I'm like, oh no, how am I going to implement trees? Because when they hit a chunk border, the tree will go away. But I think I have a trick up my sleeve. Let's do a physical demonstration right here. And in fact, I'm going to look back on this demonstration for some whatever it's called. I can't even like make this video, but I'm going to make it anyways because there's a lot of stuff to show. Use it for demonstration purposes. Yeah, there we go. Okay, let's pretend this is a chunk border. Okay, now this is where the chunk is separated. Here's a new chunk. Okay, so let's say a tree gens right here. Okay, and then this is going to be the leaves. This is definitely a tree. It's beautiful. Yeah, we'll go with this. Okay. Without an implementation of being able to assume from a data map where trees would be, if they're not like a constant definition in biome data, this chunk would never know that this chunk has generated a tree, because it would just assume, like if I use math.random to generate trees, but if I use the random noise algorithm or the Perlin noise algorithm, it's always a constant unless you give the data a different seat. So what I can do is implement a noise generation algorithm for trees, right? And I might do this after the video. Actually, I'm kind of tempted now that I'm explaining this. So this biome knows, alright, there's a tree here, but then this biome can gen, and then it can gen around it to see if there's any trees generating, or it can get the noise calculations to see if there's any trees around it, and then it's like, oh my god, there's a tree here, we need to generate this, and then it goes on and generates that part. And that's why in the Minetest engine, the biome data is actually hard-coded. Like if you generate trees using the C++ biome generation, it has a hard code basically that does the same thing. But honestly, I totally forgot that was even a thing until I literally just explained this to you guys, because I've been freaking out. But as soon as I started making this video, it came back to me somehow. I don't even know. But this will be pretty cool. Ta-da! Let's see. So the flood fill algorithm. I'm going to explain this too, or I'm going to attempt to explain this so when I review this video that not only you guys get an understanding, I can look at the logic of what I'm saying right now and then make tweaks to it to see if it makes any sense, basically. Alright, so the sun, even though it could be over there or over there, I'm not sure if I'm going to have it go this way or this way, but whatever way it goes, right? Light will only shine downwards. and then it will perforate outwards. So let's see. Let's pretend this is a column right here. Okay. So what happens is, if I do an update here, and if there's a different light value around it, what it can do is you can check up, oh, is this greater than what I am, which is currently 0, and then it says okay, and then it will get whatever's less than it, basically, and then it will flood fill downwards, and it will check if these things are in direct sunlight or not, and if they're not, then flood fill algorithm. Basically, the light source is going to be whatever the column is from here, and then perforate outwards to see if there's other light sources, and then kind of like smooth in between it. So this is 15, this is going to be 14, and now since this is a column, this is going to be 15, 14, and then 14 is going to be right next to each other, basically. So hopefully that makes a bit of sense. Torches are going to be a little bit of a different story. Well, not really, actually, because they're going to use a light source. I'm going to have a piece built into the algorithm for light sources. And the flood fill algorithm, based on the time of day, is going to set the sunlight value based on how bright it is out. And so it's going to flood fill downwards and all that stuff. And if you play old school Minecraft, like Minecraft Alpha back in the day, when the day-night cycle changed from night to day or day to night, you would see in the world the chunks individually changing light values. And actually in Minetest, I remember there used to be a bug that would it would cause chunks to be full daylight until they finally updated in memory, and then once they updated, they returned to nighttime. But I'm going to aim to actually fix that and hard code it so that it cannot happen. But we'll see. This is going to be a monstrous undertaking. So we'll see. Let's see, what else do we got here? So let's just mine to the bottom of the ocean. Another thing I want to implement is swimming. Not like modern Minecraft swimming, or what I even tried to implement in Crafter. Just, you know, old school Minecraft swimming, and just like how you swim in Minetest. So right now they're all solid blocks, but I actually already have it preloaded into the rendering engine, the collision engine, to allow you to move into non-swimmable blocks, and that's actually how air works. You know, let's test this actually. I think I might be able to do this. Steppable is liquid, walkable false. Gotta work on this, but you know, one thing at a time. We should be able to walk into the water. Yeah, we could walk into the water. I gotta make liquids not pointable too. But you can actually see it looks like you've glitched into the area, because well, basically it is glitching into the area right now, but there's no swimming either, so it just makes it that much harder to walk across this. So, very interesting. Let's see. I gotta make it smoother of a drop, because you can see how this is smooth, and then it goes down smoothly. But right here, this initial thing you can't get back up because it's just a steep dive off. Definitely gonna work on that, because I don't like how that came out, but basically one thing at a time. So we're gonna set that back to true, because for the sake of debugging. And let me just show you what happens when this first starts up. Okay, so I have to create all these objects, and oh, it actually didn't go up that much, but you can see it fluctuating. And here we go. So what happens is basically the Java virtual machine is optimizing the code as it goes. And well, I can't even have it on the same screen if I full screen it, but we'll do this just for this one video. And so it's right here. It's under the one that's GPU 3D. So you're going to see as I walk around, it actually goes down. It's very strange. It's like the garbage collector is aiming high throughput versus a blocking garbage collector. So you can see that even though I'm generating new chunks, it goes down a bit. Because the garbage collector is basically learning how the program is working with the data, because the Java VM doesn't do any assumptions based on what is happening, because every program is different. It's just analyzing what's happening and then doing a sweep up based on the two criteria of the garbage collection algorithm. There is the Eden, and then there's pass 1 and pass 2. And you can see everything's going into pass 2, becoming old. It's no longer being accessed by the Java VM, and you can see it's slowly going down. That's pretty cool. So it'll slowly go back down. If I do this, I forgot what it was. It's XMX 200M, I think. 1 second, because I want to show it during this video, because I was testing this out and it's actually really cool. Java limit VM memory dash XMX. It's not the colon. Also, it's not capitalized. XMX, okay. Okay, so now we have a VM that's limited to 200 megabytes. So you're gonna see it's going to do some seriously aggressive garbage collection. And I forgot to actually do this, because I'm gonna post this video anyways, but you know. Alright, so you're gonna see I did this flag because I forgot to turn the video back on, but now it's limited to 200 megabytes. So the Java VM will enforce that very strictly, and you can see that the Java VM is now sitting at 156 megabytes. So let's do this. Let's go, like, let's party. 100 megabyte VM limit. I bet you this is gonna crash. What the? It actually started up. Okay, Java. You can see it's trying to stay strictly within the 100 megabytes, and it actually is. What that 50 megabytes is actually the meshes and the textures, because they're cloned in OpenGL and native memory basically. But you can see this is well, technically this is running lower on memory, or using less memory than Minetest is. So I think that's kind of ridiculous, because when you go into the Minetest game engine, it's actually uncompressed. So, but you can see the reason why it's going up and down so much is because I'm dynamically creating meshes. So the fact that this is only running 180 megabytes in the game is just a little ridiculous, honestly. Let me turn out the thing again, and then I think I have a copy of Mindtest on my computer. And here we go. I got my old build of 5.3. Okay, so here's another problem with Mindtest. It starts up like this. That's as good as that's going to get. Okay, we got the Mindtest engine. The main menu is using 36 megabytes. We'll play the game. And you can see the memory usage is now equal to my game. Oh, now it's exceeding it. I'm using the wrong game, aren't I? What? Am I using a texture pack? Uninstall the texture pack. There we go. Okay, this is a better comparison. So it's using around 200 megabytes. Mindtest likes to stay around 200, which is rather nice actually. It's very optimized. Because this is actually a lot of data to process, and the fact that it's only using 200 megabytes is pretty good. Especially with the different amount of faces and rendering things going on. But basically what I was trying to show is if you optimize a Java program, you can pretty much get it around C++ level. So that's pretty cool. Oh yeah, and full screen still works. I definitely gotta work. Oh, I think I turned VSync off. I gotta work on that. I'm gonna test this on Linux and see if I can make a build that is, or make the source code be dynamic, so that the Lightweight Java game library binaries are cross-compatible. So we'll see. We will see. It shouldn't be too difficult. All I have to do is set a path, one with a folder for the Linux binaries, one with the folder for the Windows binaries, and one for a folder with the Mac OS X binaries, and the IntelliJ package builder. When you build the artifact, should automatically be able to detect what the required binaries are. Or I'm sorry, not binaries, but the jars. I don't even want to know what the frame rate is, because I remember that the frame rate actually goes up in my game when you turn full screen mode on. So VSync needs to be worked on. There's something a little, I don't know, something feels a little weird with the mouse and without, or with the VSync on. But you know. So let's try something right here. So just to show that this is a constant implementation of the seed. So we're going to remember this little bend right here, right? We're just going to walk backwards. And let's go find it again. And there it is. So what this is going to allow me to do is create seeds like in Minetest and Minecraft, and so you can generate random seeds and whatnot, and basically you can play on the same world as somebody else if you get their seed. So that's pretty cool. I don't want to. Oh god, full screen applications act weird on Windows 10 with dual monitors. Sometimes OBS will crash, so I want to be careful. I almost did it, but I think I saved the video from getting corrupted. I think I've actually covered all of the bases. That's all I got, guys. So I'm gonna work on all those things, and yeah, hopefully you enjoyed this ridiculously massive video. A lot of stuff to talk about. This was completely unscripted, so if you made it this far, thanks so much for watching. I do have a Patreon, it's on my YouTube banner. And if you have any ideas, feel free to come into the Discord, tell me, talk about them. If you have any like performance optimizations, if you're a Java developer, or if you know how to program in lightweight Java game library, all that good stuff, feel free to come into the Discord and just have a chat, ideas, whatnot. And yeah, if you're not subscribed, why not subscribe? And I'll see you guys in the next video. So, peace out.